Here we consider an application of quadratic functions. A rectangular pen for a pet is under construction using 100 feet of fence. Two questions we want to answer. First, find the dimensions that give an area of 576 square feet. Then find the dimensions that give maximum area. So think about our pen here. So we're thinking about building a rectangular pen. We're trying to decide what the dimensions need to be first to get an area of 576 square feet. So keep in mind that when we're working with a rectangle, area is our length times our width. So let's call one of our dimensions, we'll call the width x. So that means that the other width is also x. So we have 100 feet of fence total, so that's 100 feet to go all the way around. So that means one width and one length need to be 50 feet, and one width and one length need to be 50 feet. So if one width is x, we can write our length as 50 minus x, and 50 minus x. For example, if x turned out to be 10, 50 minus 10 would be 40. So our dimensions as we made our way around, we would have 10 and 40 and 10 and 40, which would add up to 100. If x was 20, we'd have 20 and 30 and 20 and 30 to add up to 100. So for part A here, we know that we want the area to be 576. So we want to multiply one length times one width and set it equal to 576. So x times 50 minus x is equal to 576. So distributing first, we have 50x minus x squared is equal to 576. So this is the quadratic equation that we need to solve. So I'm going to move all of my terms over to the right-hand side. So I have 0 equals now positive x squared minus 50x plus 576. Oftentimes in these applications, you'll be able to use factoring as a strategy to solve. This is one where we can factor. We're thinking about two numbers that multiply to 576 and add to negative 50. So after some trial and error with your calculator, you'll find that the numbers that work for this are 18 and 32. Because we want a positive 576 and a negative 50, we'll have a subtraction in each one of our factors. So if x minus 18 equals 0, x is equal to 18, or x is equal to 32. So if x is equal to 18, then 50 minus x, 50 minus 18 would be 32. If x is equal to 32, 50 minus 32 would be 18. And so for part A here, the dimensions is that we're going to have a rectangle that's 18 feet by 32 feet. So now let's think about part B. Part B says, okay, let's forget about the 576 square feet. Instead, let's find the dimensions that give a maximum area. So let's think about our area function. The area here, in general, if we keep it in terms of x, is equal to x times 50 minus x. Or if we distribute this out, we have a negative x squared plus 50x. Whenever we see this word maximum, when we're thinking about quadratics, we want to think about finding the vertex. So to do that for a quadratic equation that's written in standard form like this, to find the x-coordinate, we take the opposite of b all over 2a. So here we have the opposite of 50 all over 2 times negative 1. So negative 50 divided by negative 2 is equal to 25. So think about what this 25 is telling us. For this particular function, the input for this function is our x, which in this case is the width. The output for this function is the area. So you input 25 as the width, it'll tell you what the area is. So the 25 is what we're interested in. This would be 25 feet. So if the width is 25, 50 minus 25, the length is also 25 feet. So we maximize the area if it's 25 feet by 25 feet. So the maximum area is when it's actually a square. So when you're given an area, you want to set your length times width equal to the given area and solve for x. Anytime you want to do a maximum, that's when we want to use our vertex formula from the last section.